in part 3, we look at these two lines. So again, you do the same thing, write it in column vector form, and then you equate the two equations. So it's 2, 1, 2 plus s minus 1, 2, 3 equal to 1, 3, 4 plus t bracket minus 3, 0, 1. Then you can compare I component. 2 minus s equal to 1 minus 3t. This will give you s equal to 1 plus 3t. Next we compare j component. 1 plus 2s equal to 3. So that will give you 2s is 2. So that will give you s is 1. And you can set s equal to 1 into the first equation. So it's 1 equal to 1 plus 3t. So it tells you 3t is 0. So it means t is 0. Next you can compare k component. 2 plus 3s equal to 4 plus t. So you'll find that you already found s and s is 1. So it's 2 plus 3 times 1, so it's 3 equal to 4 plus t. So 5 equal to 4 plus t. So the t is 1. So you'll find that the equations are not consistent. You have found t to be 0, right? If you solve the first two equations, t is 0, s is 1. And if you sub s as 1 here to the third equation, you get t is 1. So not consistent. So we can say therefore the two lines do not intersect. So the two lines do not intersect. And if you take a closer look, right, the direction vector of the first line here is actually minus 1, 2, 3. The direction vector of the second line is actually minus 3, 0, 1. The two direction vectors not parallel. The two direction vectors not parallel. Because from 0, right, you can never get a 2. So that means if you call this vector u, you call this vector v, then you'll find that u cannot be a multiple of v. V cannot be a multiple of u. So because the two lines are not parallel, there will be skew lines. So in this part 3, the two lines are just skew lines. So the two lines lies on two different parallel planes. And if you look back to part 1, right, the two lines do not intersect because not consistent, the equation. S equal to 1 minus 3t for equation 1, and s equal to 2 minus 3t for equation 2. So because the two equations are not consistent, the two lines do not intersect. But if you look at the direction vector, then you'll find that the first one gives you 1 minus 1, 2. The second one gives you minus 3, 3 minus 6, which you can take out a 3. If you take out a 3 and a minus sign, it will give you 1 minus 1, 2. So take out minus 3, it will give you 1 minus 1, 2. So you'll find that the two direction vectors are parallel. So in this case, the two direction vectors parallel. So that means in this case you get actually parallel lines. So let's summarize what we have for the three pairs of lines. So this one is because they are parallel. Parallel lines, so they do not intersect. This one intersect. This one skew lines. So when given a pair of lines They can be parallel lines, so they do not intersect, or they can be skew lines, so they do not intersect, or the two lines intersect. So there are three types of situations can happen.